Welcome to Thinking Deeply About Primary Education, the podcast that makes time and space to really think about pedagogy, teaching and learning, professional development, anything of interest to time-poor but enthusiasm-rich primary teachers. This week, I'm joined by Christopher Such.
Hello again.
And together we'll try to answer the question, how do you solve a problem like number lines? But first, Chris, what you reading for?
This week I have just finished, I can't promise I've read it all in the week, but I have finished it this week. A book called Get Better Faster. It will be familiar to people on Edu Twitter as a guide to coaching of teachers, particularly teachers at the start of their career. It's a really interesting book. It's very American. It's very, I guess the phrase would be up and atom, very positive. It's well worth checking out for anyone who is in the game of dealing with early careers teachers and supporting them, or dare I say, even teachers later in their career who you want to support, who maybe are struggling a bit more. I think, having said that, I think there are elements of what's described in the book that would benefit my practice, would benefit anyone's practice. So it's, yeah, a really interesting guide to coaching. I think the reason I bring it up and the reason I want to mention it in particular is one idea that I love from it, which is about how to support NQTs through that very first week. Because I remember my first few days of being a teacher, and I don't think there's anything has terrified me as much as Monday morning or Tuesday morning, whatever it was, day one in the classroom. And one of the things the book recommends is the idea of a genuine dry run with teachers, where they're in the classroom, where you talk through, where they go through their timetable, where they take it step by step. So the next day, terrifying though it would still be, the only thing that's new to them is that the children are there. But teachers have already rehearsed where they're going to stand, what they're going to say when they ask children to line up. Having a lot of these basics drilled, for want of a better phrase, is something that I think I would have benefited from in my first week of teaching.
That sounds really interesting. I haven't read it, but I think I'm going to push it up the list possibly after your recommendation. Yeah, because it sounds like something that I think I'd enjoy, especially that idea of going as deep into that first week. It's not something everybody considers. It's not something I genuinely consider, but really should. That sounds great. This week I have been reading for the second time, Understanding How We Learn. And that's by the learning scientists Jana Weinstein and Megan Sumeraki. I apologize to both of them if I butchered their names, but I've only ever read their names. I've never heard them said before. And then Ollie Kev as well. And what I really like about it is that it makes sometimes quite dense subject matter the most accessible I think it has been, certainly in what I've read. It's in nice manageable chunks, so you could sit 5 minutes, get under the skin of something really interesting, stop, and then come back later. And then obviously, as with anything that Ollie Kev does, it's superbly presented, so it's almost like a really intuitive book. And so I think some of their best stuff, and yeah, I really enjoyed it, and I think it's probably a must read in my opinion.
Just to add in there, I remember it would be about 12 months ago, listening to some of the learning scientist podcasts. There was one particularly on retrieval. Really, really interesting stuff. And that rings true with what you're saying about the book. Really accessible, yet with enough depth to keep you interested. So yeah, highly recommend their work.
So I think that brings us nicely on to the subject matter for this episode. And it's something that I know we like to talk about quite a lot, Chris, and that's number lines. If you don't mind me asking, what makes number lines different from other representations of number?
I think the first thing to draw out from what makes a number line unique is to compare, well, the first thing to do would be to compare it to the thing that it's most closely related to, which is the number track. Now, for those people who aren't teachers further down the school, a number track is effectively a line of boxes, a bit like the bottom row of Snakes and Ladders board, 1 to however far you want to go, or including 0. And the difference between that and, say, a number line is that they both have this. They both represent the ordinal aspect of number. They're both, in other words, show you the position of number relative to other numbers. But the difference is with a number line is that because you don't have specific boxes for specific numbers, the distance from 0 is representative of the number. I mean, that is sort of the case with a number track, but it's more in discrete chunks of counting, whereas you end up with this continuous representation on a number line. So that'd be the first thing I'd say. Before I go into any other detail, I'd fire the question back at you, because this is much more your area of expertise than mine. Beyond kind of it being a continuous representation, what would you add?
So I think the number line seems to have a special place in the hearts of lots of mathematics researchers, certainly those researching early and sort of primary mathematics education, and development. Because, I'm thinking about papers by people like Teserina Nunes and stuff, where they're talking about the power of the number line. And I'll come to it a little bit later on, the connection that has between, the connection between your sort of awareness of number and how you interpret the number line. And so in terms of how it's different from other representations, it seems that a lot of people are convinced that it has this sort of intrinsic property. And, people drawing connections between, if you learn to read left to right, then your mental number line is left to right, and vice versa. So it's almost a representation that's a part of who we are. And, without going completely ethereal on everybody, I think for me, that's what makes it different, is that it almost seems more than a representation. And in some instances, I think, essentially when you boil it down, it is a representation of the distance between various points. But I think there's so much to it that it almost gives us pause for thought as to when we should introduce it, because it is so powerful.
It's interesting that you say that. It reminds me a little bit of something I read a little while back by George Lakoff about embodied cognition, where he talks about the number line being one of a few key representations of number. I mean, he sees number as something that is inherently embodied, something that we can only understand through experience, doesn't really stand any of that Platonic stuff. I would say one of the other things, thinking about it, that makes the number line different to other representations is the fact that you can start with what is effectively a blank number line. You can start with something without numbers or without anything on it, and then use it and adapt it and manipulate it to represent any size of number. So you can start with this number line on the board, and before you deal with it, it could be a number line that's talking from 0 to 10, or it could be a number line that's looking from, negative 50,000 to positive 50,000. There's a certain flexibility to it that makes it so incredibly powerful, I think.
Yeah, there's a really good paper, and it's a meta-analysis, and I think it looks at over, studies with over 10,500-ish participants, and I think they're between 4 and 14, if I remember. But it's, we've mentioned him before, Liefen Verstaffel, and he was a member of a team that was led by Michael Schneider, and they looked at the correlation between the number line and general mathematical ability. And what they said was, without ascribing any sort of causation, those with a strong understanding of the number line also had a strong mathematical level of mathematical competence. And as people got older, when they were working with, things like fractions more, the the correlation seemed to increase. And I mention that because they say one of the possible reasons is that Siegler's integrated theory of numerical development, where proportional reasoning is a key component. And they say it's possible that because proportional reasoning is so fundamental to the number line, and that sense of magnitude, as well, that might possibly be um, the reason why the number line has such a strong correlation um, with mathematical competence. Yeah, so I think it's definitely a fascinating, for something that seems so simple. It's yeah, there's so much to it.
I think one of the things that, and this is purely speculative, I'm sure I've seen a bit of research and a couple of programs on the subject that talked about the idea that children's completely untouched kind of natural understanding of mathematics is more logarithmic than the 1, 2, 3, 4, 5, 6, 7 equally spaced idea that we see on a standard number line. I think it might be the case potentially that an understanding of the number line allows children to move away from that logarithmic understanding of number. I mean, a logarithmic understanding of number kind of makes sense in nature, because what you need to know is there are there lots, and I mean mega lots, or are there not very many, or are there a number that we can, deal with our hands? So a little, a lot, or mega lots is a much more useful construct than something as precise as being able to say, oh, there are 375 of this. So a logarithmic understanding of number maybe does make more sense naturally. And thus maybe it's the case that the number line allows us to move away from that understanding, and thus a grasp of it helps us develop this understanding. Again, purely speculative, and I only really bring that up to highlight the idea about a natural understanding of a number being logarithmic, and something that people should check out because it's really fascinating. Alongside that, really quickly, I would say, and this is on probably a lot more firmer ground, is thinking about bits and pieces of research that I've seen in mathematics that relate to spatial awareness and the importance of the development of spatial awareness. And again, this points to the number line, because obviously the number line is itself a representation of number that takes quite a structured view of space. And thus, if children are going to succeed with it, their spatial awareness needs to be pretty strong, I would imagine.
Yeah, spatial awareness comes up in that paper, and I, hand on heart, don't know enough about spatial awareness to really engage with that. With when they were talking about this is one of the possible reasons why it might be so powerful a tool. I sort of said, well, I sort of put a pin in it and said I'll come back to that. But yeah, that's definitely mentioned. One of the possible reasons why it might be so important. Yeah, no, it's fascinating because one thing I'm thinking is that when you were talking there, when pupils use, for instance, a blank number line or an empty number line, how much they understand number and how much they understand mathematics will largely determine how quickly they're able to adapt to that strategy. And and it's not a case of, in my experience, the number line can give you almost like a skeleton. Okay, here's a way to approach this. But sans solid understanding of number, I don't quite see it being worth the effort to go into that new model, if that makes sense.
Mm.
So yeah, and that's what's coming to mind whenever you're talking there, Chris, is how what's the balance between what we feel and what we're moving towards. I think it's definitely worthy of consideration.
So I guess the next question that comes from that really is, and you've touched upon it briefly earlier on, when do you think precisely the number line should be introduced, and why? And I guess alongside that, can we really be precise in making recommendations?
The million dollar question, the conversation we've had a million times between us. I'd like to go to the NCTM. So that's the American mathematical body. Because they say three things about when, I think, to choose representations. So creating and using representations to organize, record, and communicate mathematical ideas, selecting, applying, and translating among mathematical representations to solve problems, or using representations to model and interpret physical, social, and mathematical phenomena. Now, I think we spent the first question talking about three, but the incarnation is probably more often than not two, where you're using this representation to solve problems. And I think that distinction has a really important influence on when we introduce the number line. So, for instance, in my gut, and last bit of that question was, can we add any degree of certainty? I don't think we can, because I think of and there's so much out there on the number line. I don't get a sense of this is when it is best to do this, but here are many reasons why you might want to do X, Y, and Z. And for me, I'm going closer to year 4, year 5. So when the pupils are 9, 10 years of age. Because I think the complexity and the idea, and you may come back on this one, Chris, the idea of the capacity for infinity and the representation of infinity on a number line, I think is almost too much if we're introduced it in year 2. Because I know possibly mentioned in the national curriculum. It's been so long since I've actually taught it in year 2, because we're more often than not using the number track. So I would have it later on, because I think there's so much to it that to get pupils to understand and pupils to get a proper sense, they need a whole lot more mathematics than they will have had access to in the first 7 years of their lives. And for that reason, I think that if we do that, we draw people's attention to an interpretation of the physical, social and mathematical phenomena that exist, rather than it being a tool which can help you sort of, solve problems. We can count, we have an understanding of ordinality, we can use this tool to help us solve a problem. But for me, and this is totally my opinion, that interpretation of the physical doesn't happen until you've got a little bit more maturity. Not much more. Like I said, an extra 3-4 years, and that's where I would go to. What about you, Chris?
Yeah, it's one of those relatively rare cases where I think we diverge on our opinions quite markedly. I'm perfectly okay with the idea of it being introduced in year 2 for a number of reasons. I think I've heard a lot of people share your opinion, and people who know a great deal more about mathematics than I do. So, people should take what I say with a pinch of salt. But I've heard a lot of people talk about the idea of infinity being an issue because, for example, the number line representation being continuous, children are inevitably going to ask, well, what could be between 0 and 1? And then you're lost in the world of fractions. Well, having worked with children in year 1 and year 2, I get children asking me things like, you get counters out and you keep counting. And children will say things like, oh, what's past 1,001? And you say 1,002. It's not long before they're asking you, well, what's the biggest number? So I think the idea of us hiding the idea of infinity from them is a bit of a lost cause if they are really mathematically astute. That doesn't mean we, bring it up and we explain it in all its detail. But I think the idea that it's something that we are effectively placing a shroud over if we don't introduce the number line isn't something that speaks to my personal experience. I think one of the other reasons I'm really a fan of the number line down in year 2 is in its understanding of just the identification of numbers. I've seen some really powerful use of numbers whereby children originally see a number line from 0 to 100, and numbers are like over the time are removed. So initially you've got the whole 0 to 100 number line on the board, and you ask children to find where's 79, where's 36, where's 50. And slowly but surely they're putting these markers on. Over time, you then take away everything but the multiples of 10. So where's 23 now? And suddenly they're kind of attuned to the markers of 20 and 30 and where 20 and 30 would be. And then over time, you remove everything but 50. And then eventually you just have 0 and 100. And children are still in that stage of, you're at a stage where you can say, well, where would 37 be? I think that ability to kind of estimate on a number line where 37 could or would be is such a powerful thing that I wouldn't want to leave it until later. In particular, it's something I've noticed when I work with children who really struggle with mathematics in year 5 and 6, is how unbelievably poor they are at that particular skill, and how quickly you can teach them it, which is such a rare thing in mathematics teaching, something that children really struggle with that you can teach quickly. And I don't necessarily think that has a transformative effect when children see that, but I do think there's something about the number line, about your ability to get a grasp of numbers, to estimate numbers when you remove many of the numbers from that number line, that just, I guess you could do that with a number track, but again, I just don't think it necessarily works in the same way. Finding that halfway point then depends on whether your number track begins at 0, whether it depends at 1. I just don't think it has that same natural flexibility to it.
Yeah, I can see where you're coming from, because like my decision to move away from that early exposure is probably only 5 or 6 years in the making, So, what are we in now? 2021. So around about 2015, 2016. Because I remember when I did the mast, I was a big fan of there's the famous Dutch study on the empty number line. And so I would have used it the whole way, when the national strategy was going, and certainly in my sort of formative years as a teacher, the number line would have been central to my practice. And I think it doesn't necessarily matter as long as the decision we're making has had the requisite amount of thought, because I'm thinking
Yeah.
like,
Sorry, yeah, I know exactly what you mean. It's how it fits into the sequence of other decisions as much as anything. How it's integrated, I think makes total sense. I don't think this is a question necessarily where there is a right or wrong, though knowing our conversations on mathematics, there possibly is. And 6 months from now on the podcast, I'll be saying, yep, I've moved number line to year 4.
no, not at all. Well, I've got a conversation in my mind with a teacher in Shanghai. We were given the chance to talk to some teachers. It must have been January 2014. And someone asked him about the number line. I can't remember exactly, and this may not have happened, but in my mind, it happened. And someone asked him about the number line, and he just laughed and said, "Why would we use that?" and that really stood out to me. As I'm like, oh, so there are different ways to interpret what I thought was a pretty sort of concrete, and this is what maths is, this is how it's taught. And so it sort of opened my mind up to asking those questions. And then obviously, recently having had the chance to really get under the skin of a curriculum, the things you outline, I know people going through having the journey that we've put in place for them will get to that level of understanding. So, and I'm looking at the picture from 1 to 6, and what are my key sort of things I want the pupils to internalize at each stage, so I don't worry so much about them missing out. But I do understand, you need to think about You need to think about what it is we want the pupils to understand, what we want them to have an innate sense of, and to be able to articulate. And then that's where a decision comes from, you know. So I think when it should be introduced and why, up for debate. But I do think it is important. You know, I think we can both agree on that. It's important, and that we should give it our fullest consideration, really.
Out of curiosity, I know it's a different representation, but it's linked to what we're talking about. How do you feel about the use of number squares? Do they take up any time in, or 100 squares, I should say? Do they take up any time in the way that you teach mathematics in Key Stage 1?
So they're not explicitly part of the curriculum journey that we've got in place, but they do feature, in board games. They do feature, in one shape or another, from nursery all the way through to year 2. But are we explicitly demonstrating their use? I don't think so. Again, I've taught like that in the past. I have used 100 squares in the past. I've got a preference for the number square. Was it begin with bottom left hand corner? We've got number 1. As opposed to the one that I would have been introduced to whenever I first started teaching, where 1 is at the top left hand corner. But I think it's supplementary rather than a fundamental part of what we do, because again, I think that correct me if linear isn't the right word, but I think because that understanding is probably our focus, being able to see this this sort of ordinal sequence of numbers. I think because that's our focus, the track is front and center, and eventually moving on towards the number line.
Yeah, I think there's something much more intuitive about a number track relative to a number square. I think obviously the power of it is that it demonstrates to some extent this idea of the patterns with tens and ones, which is perhaps of value. But yeah, I like the idea. The thing about the number track in comparison to the number line and to the 100 square is that even if you don't do this exact thing, though I think you can do with smaller numbers, if you were to put a counter under each number, you can immediately relate the cardinal to the ordinal.
So then we thought about when and why. What uses does the number line have?
Well, I touched on one earlier with regards to recognition of numbers between, say, 0 and 100. And obviously that can apply to recognition between any two given points. So I think the idea of identifying and using a number line for comparison is really valuable. I think it has some quite, in some ways, limited compared to the number line manuals I used to be given back in the day that suggested that it was a panacea. It does have some areas of arithmetic for which it's useful. I think in particular, the idea of demonstrating compensation in mental arithmetic as a visual model of compensation. So for example, were we to add 199, seeing that as adding 200 and subtracting 1, I think that that's a nice representation to show the logic behind that. I think it can be quite powerful when it isn't a blank number line, when it's all the numbers are labeled. I think initially talking about things like skip counting, when you're talking about counting in 3s, counting in 5s, counting in 2s, equally the number track is great for this. But for those who do introduce the number line, I think it can be equally valuable for that. I think where it really comes into its own is in things like rounding. I find use of a blank number line really powerful for rounding, because often I've seen rounding taught in a manner that doesn't really respect the idea of magnitude, doesn't really grasp this idea of saying effectively what is it nearest to, which is what we're really hammering at when we're talking about rounding. And the representation on a number line really hammers that home when we're saying, round 347 to the nearest 100. It goes back to what I talked about earlier about identifying numbers, being able to say, well, here's 300, here's 400. what would be halfway between the two? Where would 347 be? And thus, which 100 is it closest to? Which one does it round to? It gives this sense of understanding of rounding that goes so far beyond the little rhymes that people use, like, 5 and above, give it a shove, 4 and below, let it go, which doesn't really contain any understanding within it. So I think it's great for rounding, really fantastic for rounding. I like the way that it implies negative numbers. And you might argue, and I think it's probably true of the number track as well, that if we start counting, 0, 1, 2, 3, 4 along a number line, as we do with the number track, the question may jump into a child's mind as well as, well, infinity, what happens if we keep going that way, or the infinity of numbers between numbers. There's also the idea implicit within it of, okay, so if this is a line, what's to the left of 0? Assuming we're orientating it the traditional, way that we would do in the UK. So I think it then becomes a really useful tool for calculating with negative numbers. So for example, if we were to say something like -2 add 5 gets us to +3, being able to see why that is, being able to show that as a jump to 0 and then a jump beyond, and the partition of numbers within that. I think that's a really valuable way of dealing with negative numbers. I have to say as well that in terms of dealing with time, differences of time, in particular, where you have a start point and an end point, or you have a duration and you have a missing start or a missing end point, it's a really valuable way of dealing with numbers. In that sense, it's where I've by far and away where I've had most success in teaching children number problems. Partly, I think, because it allows children to visually see and remind themselves that we're no longer counting in base 10, but we're actually dealing with, we are dealing with base 10, but alongside that, we're dealing with kind of a base of 60 to an extent, which is obviously a key component of dealing with minutes. So, yeah, I think there's a lot to be said about the number line for those particular aspects. No doubt you've got more to add, or even to disagree with those. What do you think?
Yeah, those some great examples. Thinking about negative numbers, Charlotte Hawthorne does a really good, I can't remember which maths conference it was. It was online, and she models really well how effective it can be in that instance. And I'm thinking about my oldest, and he's just naturally inquisitive about things to do with mathematics. And so he was listening, people talking about -5 and -6, and he wanted to know more. And so the first thing I spoke to him about was the idea of, a number line, and yeah, he really clicked onto that, and the movement. So I think it can be really powerful in that instance. And did you mention as a model of the difference? I think you said comparison, didn't you? So I think probably worth clarifying that comparison and the difference are essentially two ways of describing the same phenomenon.
Mm-hmm.
Yeah, so yeah, really powerful in that way. I think it's Pete Maddock, that's his go-to, I think, in visible maths. And I think it's a really powerful one. And when you talk about time, I always talk to pupils in year 5 and 6 when we're solving problems involving time. I always start off by telling them, this isn't how time really behaves, but this is a really good way of describing how we think it behaves, and how we believe it behaves. And because obviously, I should have made Carlo Ravelli my what you're reading for, because he does a really good sort of hourglass, two triangles on top of each other to describe how you've got the present, and then you've got all the possibilities that could have happened before, sort of spacing out, and then all the possibilities that could happen in future. But obviously, you're not going to teach that to year 5 and 6. What I said earlier on about how much the pupils already know makes a big difference. Pupils who have a really good sense of time and durations can look at a duration problem and make a jump of 2 hours, a jump of 30 minutes, and a jump of 10 minutes, and they can be at the solution. If they don't have that understanding, then they could jump 10, jump 10, jump 10, jump 10, jump 10. And I think it almost makes the utility redundant. And so that's why I say what the pupil knows and what the pupil already understands makes a big difference. I don't know if you've ever encountered that before, Chris, but yeah, but those pupils who are good with time, they understand the idea of hours and minutes and um, all the things that are really sort of fundamental to that understanding of time that allow you to solve problems that involve sort of an expiration of duration. For me, in my experience, it makes a big difference. But yeah, but I think, what can I add to that? So one of the fundamental things that we use the number line for is an expiration of decimals and fractions. Um, and I think, again, it goes back to what we're talking about, proportional reasoning and this sort of sense of magnitude. And so one of the key things we do is we look at the relative size and how the distance on the number line impacts on the placement of a decimal or a fraction. Um, and I think, you'll see, and you've already alluded to it a little bit, I think Colin Foster will often share questions on Twitter, and he's got several different number lines. And one small change will impact on the placement. And I think really getting under the skin of the magnitude without the use of base 10 equipment, for instance, it's another way of thinking about the relative size of different numbers, whether they be less than zero, um, or whole numbers. Yeah, so I think that's key, and that's the kind of thing that I would explore in year four, certainly year five, and then possibly a little bit more in year six.
Yeah, I mean, that makes a lot of sense. One of the key aspects of the understanding of decimals at first and fractions at first is getting it on that number line and seeing that there is a sense in which fractions don't necessarily, well, we talk about fractions being a fraction of something, so a quarter of 4, but helping them to understand this inherent idea that when a quarter is on its own, it's a quarter of 1, and that idea is almost a given. I think the use of a number line can help that. Lots of counting in quarters or in fifths or in other fractions with other denominators. It's a great way to, I find as well, to get around this problem that children have with denominators. This idea that, what it's like. You ask children what's larger, a third or a quarter, and at first a common misconception is that a quarter is the greater fraction, because they're just so used to this idea of 4 being more than 3. Whereas a number line, particularly, dare I say, one that's quite flexible, a digital one that you can make that change quickly, being able to show a number line from 0 to 1 broken into 4 increments or broken into 3 increments, and then just immediately being able to see that, actually, you can see that increment where it's a third, that is larger than that increment where it's been broken into quarters. It's a really valuable representation to help them overcome that misconception. So I think it's, really important that you brought up the idea of decimals and fractions.
And I think it's that understanding that differentiates those pupils who will be guaranteed almost success in the secondary phase, and those who will have to work that bit harder to sort of enjoy mathematics. And you'll often see it. I think it's like what's the phrase with, is it like it's not a latchkey, but there's something similar, but really I think if you've got that a solid understanding when you leave primary school, then the rest of mathematics is so much easier. I don't know, what do you think, Chris?
Yeah, I agree. It's often been first port of call for me when working with certain children to see what their mathematics, their underlying mathematic skills are at a given moment, their underlying mathematical knowledge, to look at their understanding of the number line, in particular, like as I said earlier, their ability to estimate with a number line. For me to be able to say, well, here's 0, here's 1,000, where would 750 be? And then to say, well, okay, now it's 0 and 10,000, where would 750 be? And that's quite a high level skill. I think, for example, that Gareth Metcalf, who was on your show a little while back, he's done some absolutely amazing activities relating to number lines that really ensure that children think deeply. There's some great stuff there. Naturally, a lot of the stuff we do with number lines is stuff that we can get children to deal with on a whiteboard by drawing blank number lines, but there are also a lot of really valuable online resources I know out there. What would you point teachers towards in this area?
So I know you've got quite a few, Chris, so I won't take those. But my go-to for, the last however many years had been the ITP materials that we used to have on CDs way back when. But essentially, they've got lots of models and images that you can manipulate. And they've got quite a few interesting ideas in terms of what you can do with Numberline. And I think it's Maths Frame. They have repurposed it so that Flash isn't necessary. And so quite often I'll go to that and it's freely available. And I will use the ITP because I think it gives you a certain amount of flexibility in terms of what you want to draw attention to, and I think it's, the ITPs for me were one of those things, let's not throw the baby out with the bathwater, so when everything changed in 2012-ish, when we had the, sort of started to see the national curriculum we're working with now, there were still lots of really good stuff, for me, the ITPs, and all the really good work that had been done on reasoning, were probably two of the fundamental things. I thought, well, I don't want to lose this. So that's what I say. I'd say go to, if you want an online resource that's particularly useful for the number line, the ITP. I'll say that slowly just in case no one has any idea what I'm saying. Because it does happen. The ITPs are for me, essential, and it's fantastic that Maths Frame have made them available without the need for Flash.
I'll introduce a few more, but first I'm going to answer the obvious question, which is, well, why do I need more than one? Each of the Numberline online programs that I'm going to describe can do basically all of the jobs that you want them to do, or most of the jobs that you want to do with them. But each of them has their own advantages that I'm going to describe. And it's well worth just bookmarking all of them because of the slightly different advantages they do have. My go-to is usually mathslearningcenter.org. It's Maths Learning Center. Center is spelled the American way, so I presume it's an American website. Is a really flexible way to deal with a number line. You can bring up bars to show things like addition, so it's great for modeling compensation on the board. You can change all sorts of bits and pieces. It's also one of these ones where you can scroll from left to right quite smoothly, so that if you wanted to show 0 to 1,000 and you can't fit it all on your board, then you can have it all on there while still showing children this continuous nature of number. That's a really great one. There's also loads of other good stuff on Maths Learning Center, so I'd highly recommend people check that out. Mathsbot.com has a really flexible number line, particularly great for things like fractions, decimals, percentages. I love the way that you can remove numbers at random. You can get it to almost set a question for you. You remove random numbers and children have to fill in the ones that are missing. That's really good. The best one, I think, for rounding in particular, which I think is a key use of number lines, there's one at mathsisfun.com called the zoomable number line. If you type in zoomable number line into Google, this will be, I believe, the first one that comes up. Again, really valuable. to be able to zoom in and out of a number line as well as moving left and right, because it just gives you whatever aspect of the number line that you want to focus on with children quickly. But it also allows you to say, show 400 and 500 and say 450 in the middle. And once you've said, oh yeah, I think 436 is going to be here, and so it's rounded to the nearest 100, it's 400, for example. And then you can zoom in and say, see, can you see all the numbers in between now? You can see that they're just hidden. They are here. But you can equally go further and further into dealing with decimals, etc. So that's a really valuable way of getting a grasp of number. The one bonus one I'll chuck in there, other than those key three, is it isn't so much a number line itself as a little program that can play with number lines. It's called, if you type in sign of the times, but sign spelled S-I-N-E, so as in cosine. Type in sign of the times, zooming in on place value. There are a couple of pages on this, what I assume is a blog or website, that basically have these little games that really support children's understanding of place value. So for example, you can get children to estimate between two numbers, here's 0 and 10, where would 4.36 be? Just like I've described before, but this time, once you take a guess, a chunk of the number line kind of zooms out and spreads out. So you can, and then, so first you'll have had, for example, 0 to 10, and then it will spread out. So you can see tenths, and then a chunk of that will spread out to see hundredths. And if you're going to 3 decimal places, a chunk of that will spread out to show you thousands, giving you a real grasp of the minute detail of where something like 4.367 is on a number line between 0 and 10. It's really worth checking out and having a little play with. It's a great final activity almost once you've really got to the stage where your children are grasping place value and you just want to hammer it home with a little bit of estimation. It's a great little site, so I'd highly recommend you check that one out. So we've got mathslearningcentre.org, mathsbot.com, mathsisfun.com with the zoomable number line, which is great for rounding, and sign of the times, spelled S-I-N-E of the times, and that's zooming in on place value. They've got one for decimals, which you can adjust to different decimal places, and one for numbers for integers, say between 0 and 1,000. So really great for different age groups.
Nice. I had MathsBot and Maths is Fun on my list, but what I really liked about yours was that you were demonstrating, and this is why I didn't want to steal them away from you, you were demonstrating that the number line you choose and the functionality it has will be very much driven by what you're trying to draw attention to. So really thinking deeply about what it is we want to achieve. So I think we could go on for a long time, and I'm probably one to revisit in the future. But I think we've probably covered as much of number lines as we are going to in this episode. So I think before we finish, let's turn our attention to a question that I found really interesting on social media, and I think it was along the lines of, what is the value of constructing a reading spine?
I'll start with the mundane. I think one of the things about plotting out the journey that children will experience in terms of literature, and also the aspects of reading that don't relate to novels, is that you can then make a commitment to it and buy some books, get them into your school, one between two. And even if this is a process that takes a number of years, you get to a stage where there are enough books that match the needs of your school, so that your reading sessions can have reading material in them without having to do lots of photocopying. Incredibly mundane, but it also is such a time saver for teachers. It means children can experience books in a much more pleasant way. But yeah, so the first thing, it allows schools to invest in quality books that they can, that the children can read from. The second thing is it forces a certain level of thinking on schools. It makes them really think about their reading offer. It makes them decide and plot out that reading journey for children. So it means that schools start to say, oh, actually, well, looking at the books that we're reading to children, there's a lot of male protagonists here, or there's far too many fantasy novels. There isn't a balance of what we're providing to children. So it allows schools to provide that balance from across the entire school. I think another thing that it can do is that it can really supplement your curriculum. So both in terms of the novels that children will read, but also the aspects that don't relate to literature. So I'll give you an example. My school curriculum doesn't contain an aspect of study in history that relates to a South American civilization. So we supplement that through our reading curriculum by having a week in which we read in different aspects about the Mayans. So it can supplement the curriculum, but it can also tie in other aspects of the curriculum. So you can start to say, well, we'll be reading this story that's set on the Isles of Scilly. So I need to talk about what an island is to children. Maybe I'll introduce a non-fiction text the week before that gets them ready for this, to understanding this environment. Once it all fits together, you've got something quite special in a reading curriculum. But that only happens if you've developed a reading spine. The last thing I would mention, and I've obviously mentioned it a couple of times already, but quite often when it comes to reading spines, schools think about the literature that their children are going to read. And that's fantastic, but that should really just be the start. We really want to ensure that children have a very well thought through offer for reading when it relates to poetry, to information texts, to other forms of text, other arguments, speeches, this sort of thing. That ensures that what they're getting is balanced and well thought through. So in short, there are practical reasons like the purchasing of books, and there are also some quite important other reasons that relate to the curriculum offer that you're giving to children. The very last thing I'd mention, actually, because it's absolutely essential and something that I was brought to my attention by Matt Swain, one of your previous guests and a friend of the show, is the importance of being able to take your reading spine and have it reflect your community, offering them in the expression that you might have often seen when it comes to reading on EduTwitter and other places, offering them both a mirror and a window. So allowing children to see themselves reflected in the books that they read, but also to see a wider world brought to them. And that's one of the things that you can really achieve quite carefully if you put a great deal of thought into your reading spine.
Yeah, it's such an interesting subject, and one on which, if I know anything, a good chunk of it comes from Matt.
I think we'll have to schedule an episode where you and Matt sort of share more on your thoughts, because that really is, so an excellent example of really thinking about our craft. Nice, fantastic. Thanks, Chris. To everyone at home, thank you for listening, and we'll see you next time.